In this lesson, you'll learn to simplify mixed expressions and complex fractions. How are rational expressions used in baking? Caitlin bought 2.5 pounds of chocolate chip cookie dough. If the average cookie requires 1.5 ounces of dough, the number of cookies that Caitlin can be baked can be found by simplifying the expression 2.5 pounds divided by 1.5 ounces. Recall that a number like 2.5 is a mixed number because it contains the sum of an integer 2 and a fraction 1/2. An expression like 3 plus the quantity x plus 2 divided by the quantity x plus 3 is called a mixed expression because it contains the sum of a monomial 3 and a rational expression, the quantity x plus 2 divided by the quantity x plus 3. Changing mixed expressions to rational expressions is similar to changing mixed numbers to improper fractions. Once again, to add fractions, we need a common denominator, which is going to be x minus 2. And if it makes you happy, you can put times 1 over 1 here, but it doesn't need anything. So when we distribute, we're going to have 3x minus 6 over x minus 2 and 7 over x minus 2. Now we can add our numerators, so we get 3x plus 1 over x minus 2. I kind of feel like this is a review of what we've already done. If a fraction has one or more fractions in the numerator or denominator, it is called a complex fraction. You simplify an algebraic complex fraction in the same way you simplify a numerical complex fraction. If we had 8/3 divided by 7/5, dividing is the same as multiplying by the reciprocal of the second number. And we multiply straight across. So in the same way, if we have a over b divided by c over d, we're going to multiply by the reciprocal of the second number and multiply straight across. Any complex fraction, a over b divided by c over d, where b does not equal 0, c does not equal 0, and d does not equal 0, can be expressed as the quantity AD divided by the quantity BC. Suppose Caitlin bought 2 pounds of chocolate chip cookie dough, and if the average cookie requires 1.5 ounces of dough, how many cookies could she make? First of all, it'd be nice to have everything in one unit. So we're going to change pounds to ounces, and we get 32 ounces. So when we divide by 1.5 ounces per cookie, the ounces cancel out. And we want to change 1.5 to an improper fraction, and then that's going to be the same as 32 over 1 times the reciprocal of the second number. So it looks like she could make 21 1/3 cookies. I'd probably eat the 1/3, so 21 cookies. These are nice and quick. I just went ahead and changed the division bar to times the reciprocal of the second number. So our A's cancel, and our B's cancel, and our C's cancel. So all that we have left is a to the 4th c squared over b cubed. Our directions are really simple, simplify, but it looks kind of complicated. So I thought I'd put this little note in here. Recall that when applying the order of operations, simplify the numerator and the denominator of a complex fraction before proceeding with division. So to simplify the numerator, I need to get a common denominator in the numerator, which is going to be b plus 3. Multiplying that out, I have b squared plus 3b plus 2, then all over b plus 3 over b minus 4. Just so happens I can factor the numerator. I can see factors of 2 that give me a sum of 3. And so now I can change it to times the reciprocal of the second number, which would just be 1 over b minus 4. Unfortunately, on this specific example, nothing canceled out. That's odd. Normally it does. So I just get what I get, b plus 1 times b plus 2 over the quantity b plus 3 times b minus 4. Write mixed expressions as rational expressions the same way as mixed numbers are changed to improper fractions. Simplify complex fractions by writing them as division problems.